Fritos, crispy chicken sandwich, or crispy chicken salad. Spartan Grill, spicy chicken sandwich, hot ham and cheese melt.
Just like on Friday,
Beauty day, I want golfers.
wherever you do your daily quizzes, whether you have a separate section for it, a separate notebook, do it on the back page of your homework, whatever it is, make sure it's labeled. There it is.
Freshmen, your petitions for freshman student council positions can be picked up.
Remember, open notes, open resources, open everything except mouths. I want to know what you know, not what your neighbor knows.
All day during regular school day, 15 to 3:15. Officers, elected as president, vice president, secretary, treasurer, and class representatives. If you have any questions, stop in the main office and speak with Robbie. Juniors interested in taking the CSAT exam registration deadline is September 8th. Stop in the counseling office for more information. Again, if you're interested in helping community members paint a mural under the rec path wall, Hillview Street Bridge, see Mrs. Folks or Mrs. Howard. Anime Club meets today over lunch, and this is a light alert to all anime fans are encouraged and welcome to join. Any and all class schedule changes must be completed by the end of the school day today. And tomorrow morning is what you are in. Student IDs be handed out today during sport time. Students who did not get the photo or did not receive an ID card today need to stop in the office as soon as possible. Seniors, you can pick up your IDs in the office today after 3rd block. So please stand for the pledge. To the flag.
Of the United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
A great week.
Okay, y'all got to be patient with me. Again, got 100 new kids. Hannah. Taylor. Are you in any way related to Angela Alonzo?
No.
God, you could be sisters. Okay. Holden. Uh-oh. Other Taylor. It's going to bother me. Paul. Rudy. Anna. Oh, yeah, that's right. We have the Anna thing. Okay, gotcha. Okay. Lars. Andrew. Ella. Mariah. Claire. Oh, yeah. In any way related to the Easton or Drum families?
No, I have one sister who's in 7th grade.
Huh.
Yeah, there's a lot of options.
No, I mean you just look like those two. So. Grace, Natalie, Anna. See, I recognize ones I've had before, or we got the family. Aubrey, Maddie, Colby. Okay. All right. Remember, I don't care how you do this. I just care that the correct product is on your paper when you're done. Go ahead and look at examples. Look at the book. All your notes. I think I handed out that, what was it, the holy sheets for the whole class. That's got a bunch of stuff about quadratics right there, first page. Review. use any of that. I just want to know what you know.
You can use the old sheets on it.
Yeah, open everything. I don't remember what I said on which day, which class. My only stipulation on quizzes is that all of you put your phones and smartwatches and all that stuff over on the counter. That's it. No. Come on, Frank, keep up. Anyone still rolling? Okay. No ding. I wish they would get us smart boards that didn't belong 2 decades ago. Alright. To find the vertex, axis symmetry, y-intercept. Got a couple of options. Option 1 is I go manual. X is negative b over 2a. Plug in there, negative 12, negative 4. Altogether, positive 12 over negative 8 is a negative 3/2. What does this get me? The x, okay, I heard x and then axis of symmetry. X portion of the coordinate for vertex, because the axis symmetry goes through it. So I know I've got 3/2, negative 3/2. I know I've got an axis symmetry. What do I do with it? Okay, so we're going to say the function of negative 4 by thing squared minus thing minus 3. There it goes. Negative 3/2 is 9/4 negated. No ding! Fix the ding. If I have to fix the ding, you fix the ding. Come on. Like, it's no big deal, just make it stop. Okay, negative 12 and negative 3/2 is 12, so 18 is 6. So I know I got a vertex now at negative 3/2, 6. Because it's a terminating decimal, okay. Moving forward, don't do that. I mean, negative 1.5 is, yeah, that is correct. But, as we learned before, so much of the stuff that we do mechanically with these, it's easier with fractions, especially improper fractions. If you go to decimal town, things get really messed up. Case in point, completing the square, which is one of our methods for solving quadratics, which is one of the things we're doing today. So, here, yes, there, no. All right. Did anyone use a different scale with theirs? Because what is this going to do to my graph? Vertical stretch by factor. So it's going to be a skinny mini. If you change the scale of your graph to match that, okay. Because otherwise, I'm not even going to be able to fit my full 5 points on here. Like, normally you want vertex and then 2 on each side to show that curvature. I do not have enough room on a scale of 1 graph to show those 5 points. So if you had scale of 1, yours probably would have went further down. Maybe you only put 3 points on there and then kind of winged it for the ends. I'm going to go by a scale because I want at least those 5 points. So I'm going to make my whole y-axis here go by 2s. That's me. That didn't have to be you. I'm going to put my vertex at negative 3/2, 2, 4, 6. I'm going to label it as such. From there, perfect square steps to finish it off. From that point, I can go over 1, down normally 1. This time I'll go down 4. Go over 2, down, normally 4, this time 16. That's why I had to change the scale. So I'm going to go over 1, so still halfway through the box, down, 2, 4. Over 2, down, 16, 2, 4, 6, 8, 10, 12, 14, 16. Over 3, down, not 9, 30 friggin' 6. So way down there. Super tall, skinny thing. Any tall kids in here tired of hearing the words you should play basketball? No? Yeah. Just like any guy who's got a little girth to him is told from like 6th grade onward, you should play football. You just want me to stand there and get hit. There you go. I got those things. I need to make sure I label everything. I have my axis of symmetry. I have my vertex, my y-intercept. Technically, I didn't have to really do anything with the graph to find my y-intercept. What is it? Because if I put a 0 in for x, the function of 0, I will get -3. So I'm just going to come over here and lo and behold, that's exactly where it is. Y-intercept at 0, -3. So in terms of your points, how are we going to score this? Where's thing? We'll do blue. Did you have correct vertex? Did you have y-intercept? Did you have axis of symmetry? Did you have the correct stretch to it? Did you actually have it 4 times the size? Whether you changed the scale to match that or not. Who in here changed their scale to go by 4s? Right? Because then you could just do the 1, 4, 9 thing. You just change the scale. And then also for going negative, meaning it is a downward facing problem. Okay, so axis symmetry, vertex, y-intercept, correct stretch, correct direction. Those are your 5. Now, naturally, what if I forgot that negative at the very beginning of the problem? Not only would it go up, but I would also have a completely different vertex, right? Because now my axis symmetry would be on a positive 3/2. I would be putting a positive 3/2 in here. So now my vertex would go way down here. It would just, the whole thing, right? The process. If you go through it and you're like, okay, I did all of that, but just facepalm right at the beginning, I missed a negative. I know exactly where my error is. That's a 4 out of 5. Okay? You know where your error is. You did the process right. I'm okay with that. But you have to know exactly where it is. If you have no idea where it is, okay, now that brings you down to at least 3. And on and on and on. With these, do you have any questions? Like, about how to score them? I would rather you ask the question about I did this thing instead of just trying to wing it. Anything? Cool. I didn't explicitly go through it last week, but -4, -12, -3. Do y'all remember -4x² minus 12x minus 3? Y'all remember how to find the vertex of this thing? Okay, second, right above trace is calculate. Calculate is found in 2 different places on the PIA 43. First is stat calculate. That finds stuff from your table. Second calculate, it's up with all the other graphing buttons, finds something on your graph. So if I want to find that, I'm going to second calculate, and it gives me all those options. I got a maximum, so you got to be careful. Read the bottom. What does it say? Left boundary. If, okay, like you see where Blinky is right now? What if I put it there, and then I was like, oh, oops, I screwed up. Well, I'll just put it on the other side for the other one, right? It's still in between. Come on, Frank, let's go. Okay, it's still between them. Look where the arrows are pointing at the top. I want you to find the maximum in here. Right? As soon as I do that, we talked about this, I don't know if it was in this class or another one last time. Just because you get the quit message doesn't mean you just quit. Read it. Down the bottom, what does it say? Your right boundary is less than your left boundary. You swapped them. Okay. So you go back and you calculate. You'll know that you don't have to actually physically move Blinky around. You can just type numbers, right? So I can just say at -4 and 2. As long as they're pointing in at that vertex, you're good. It's going to ask you for a guess every time. I always tell it, screw you, you can tell me the answer anyway. And skadoosh. Okay. Tiny bit. Because what it's doing, there's an algorithm to this. If you remember a bunch of the polynomial root theorems, we're going to review them in here, where you did like big hard swath signs, the upper and lower bound limit test with synthetic division. There's a bunch of stuff that you can do with polynomials. When you're picking the two numbers on either side to find a feature, it's putting those into an algorithm, which is why you see that tiny little bit of round off error there. We know this is at -3/2, and we're going to be smarter than the calculator. That round off error is because of where I put Blinky. Okay? Kind of like, all right, not everyone's as well versed on the calculators. What if I did this to find one of the zeros, and it said that. What is that?
The Labor Day savings inside the Home Depot means something different.
A ridiculously small number. Y'all remember exponential or scientific notation?
Out there,
that says times 10 to the -25th.
Finished. In here,
that
it's
means
a bag of Miracle Grow garden soil.
1.
Out there, it's a lush backyard that's worthy of
203. Now move this decimal this way
with
25 times.
Savings for housewide doing. Only at the Home Depot.
What goes in all those spaces?
Outdoors get more done.
If I saw 24 zeros before a number, what would I say this is? 0.
Sure,
okay,
you may be
but it's going to have that
just
tiny bit of round off error because of where I put Blinky.
The chicken sandwich is.
Okay,
but that's just the beginning. The full crispy,
so,
juicy, tender experience.
if I'm ever doing something up here with the calculator and you're just like,
but why stop there?
Yeah,
Order ahead on the app and get medium fries and soft drink for free. Now
Stop
that's a deal that tastes even
okay,
better
because I
than
know
it sounds.
not everyone actually used these things in Algebra 2.
9:19, 10:11 to 10:31.
All right, with that,
one time per week. McDonald's app download and registration required.
Homie work. Can we graph stuff? If there's anything on there, you speak now or forever hold your pieces. Yeah. Okay. How about we just come back to this one? All right. As an example of domain and range. The commandments of domain. The 3 that we know are what? Thou shalt not. Divide by 0. Do I have anything in my equation that has x on denominator? So we're good. Thou shalt not. What else? Even root of negatives. Square root, 4th root, 6th root, 28th root of a negative, you can't do it. Do I have an even index root up here? No. So we're good. Thou shalt not take log of non-positive. That was new last year. Do I have a logarithm anywhere in this equation? No. So who's not allowed to the party? Who's going to break the rules? No one. Well, I mean, yeah, but I don't have them, right? Because I never had that square root of the negative anywhere in here. So since everyone's going to follow the rules, domain is the x's that are allowed into the function. In this case, all real numbers. Because there's nothing that's going to break math here. Didn't I do this on Friday? Oh, okay. Upside down A is for all. It is You use it in mathematical proof. Yeah. If you just put the real number set, we're good. Range. So if domain is everyone allowed into the party, inputs, X's, then range is everyone allowed out of the party. Was there a restriction on what Y's can come out of this function? Sure was, because we had a maximum. So my range can be written as y is less than or equal to 6. You can write it as negative infinity to 6. You could write it in set builder notation, all y's such that y is less than or equal to 6, y element of the reals. Like, you could do any of those and they're all correct. Right now. This we review beginning of chapter 1 on the same day as interval notation. If you already know interval notation, cool. If you don't worry about it. We're going to go through it. That's why I say right now, if you want to just write that, I'm okay with it. But domain and range are what X's are allowed in, but more appropriately, what X's are not allowed in. Restrictions to the domain. And range is everything that's allowed out. That's it. We're going to talk a lot more about domain and range in chapter 1 because it's in-depth analysis on function graphs. So, okay, besides that, whole domain range thing, which is to be expected. We don't hit it nearly as hard in Algebra 1 and 2 as we should. Cool. Then, we left off with this. We're graphing some quadratics. We're going to move into solving them. Gotta get on this page on, what is it? PreCalc, student folder. Holy sheet! There it is. Okay. On your holy sheet, you have an old, okay, here's all that stuff, right? About how you graph them, what your vertex looks like. Real quick, I'm going to review it in another section, but y'all remember transformation form? Vertex form? Move left or right, up or down, vertical stretch or compression, all that kind of stuff. Okay, you should have beat that to death in Algebra 2. It was in every single chapter. It was in almost every single chapter. We didn't do it in systems and we didn't do it in probability statistics. But that one should be very, very familiar if we run across it. Down here, a factoring decision tree. You ever seen something like that in any of your other classes? You've been factoring quadratics for 3 years. Okay. Step 1, actually step 0, is to get ax squared plus bx plus c equal to 0. You always set things equal to zeros because solutions are x-intercepts, are the roots, are the zeros of a function. So stage 1, if you got a greatest common factor, factor it out. If it doesn't, or you did it, move on. Are A and C perfect squares? Because some of those are special types. Okay? If yes, does it have a middle term or not? So it may, now this like 90% of the time, it's going to be one of these. Sometimes you get perfect squares A and C, and they actually have to go for a full AC method. You remember ones like 9x squared minus, I don't know, 225. those. Okay, you see the perfect squares. Yes, it does not have a middle term. That means it's a conjugate pair. Square root of this guy, square root of that guy. You notice how this is 3 and 15, both divisible by 3. That's 3 and 15, both divisible by 3. What could have I done at the beginning? They're both divisible by 9. So I take that 9 out, my GCF, getting x squared minus 25, which is now 9x minus 5x plus 5. Okay. Because I could have taken a 3 out of here, I could have taken another 3 out of here. If you look, 9 was my greatest common factor. Okay? So, we had perfect square ones that were kind of special. If not, then we ask the question, does A equal 1? Those are the nice ones. That's like x squared plus 7x. Those are like the first ones you want to have factored, right? What are factors of 10 add up to 7? Okay, so those were your split right here. If not, if I started throwing something in the A spot besides 1, then we had to do factor by grouping. And there's a full AC method for it. So let's review real quick all that business. Starting with, do I see any greatest common factors? Nope. Wait, are you sure? I see 8 and 12. But there's nothing in the A position. You have to make sure. When you factor something out like that, you are the equal opportunity bully. You're like a bully with a conscience. That's me coming up to this table and being like, all right. We have $2. I'll take $2. Give me your lunch money. I got $10. No, I'll just take 2. You're cool. Give me your lunch money. I'm broke. I got like pocket money. Oh, here you go. You can have your $2 back. Equal opportunity bully. If I can't take $2 from you, I can take from them. Bully with a conscience. Okay? I don't see anything in front of that x squared that matches with the 8 and the 12, so I can't take anything out. Are A and C both perfect squares? 1 is, but 12 is not. Now I could do square root of 12, but it's not a perfect square. So I head on down the train and I say, is A equal to 1? Yes, it is. So what factors of 12 add up to negative 8? If you have to do the full list, do the full list. I hope you don't, because that'd be rough. So I would just say x minus 6, x minus 2. You know how many kids get there and then quit and then get 1 or 2 points off, right? Read the instructions. Reading the problem explains the problem. Solve. You got to remember there's still an equal 0 here. What do I do? Set each equal to 0. It's built on the concept that if A times B equals 0, what has to be true? One of them is, right? One of them is 0. So I set each equal to 0 and solve them individually and say x is 6 and 2. Okay, those are the easy peasy ones. Those. Find something with a little more oomph to it. There we go. No, if you want to say x is 2 and 6, x is 2 comma 6, you want to throw set brackets on there. I always put just and in between. This one. No greatest common factor. A and C are not perfect squares. A does not equal 1. We have to go through what is called the AC method. How many of you had a teacher that said, just do this, you know you're going to have C's here. Start guessing and checking all the factors of 2 and all the factors of 4 until you hit the right one. That is brutal. No. We don't do that. Even, like right now, I could probably do that. In fact, if you're in PreCalc, odds are most of you could very quickly just mental math factors of 4 that are going to make this work. Because the only way I'm getting 2c squared is if I have a 2c and a c. It's a prime number. Most of you could do this in your head. Just real quick, factors of 4. Which one do they go where? Foil it out in your head, all that kind of business. And say, well, I got to have a positive 4 here and a positive 1 there, so that I'll have 8, 9c in the middle. Okay? If you can, cool. If not, we have a full algorithm for it. Step 1 is always the greatest common factor if you got one. Step 2, you find what factors of a times c add up to b. So now I'm not just looking for what factors of c add up to b, it's a times c. So, if that's 8, well, what
This
factors
Labor
of
Day,
8 add up to
HomeDepot.com is your one-stop
8 and
shop
1.
for all things decor, with up to 30%
So I will use
off
that
furniture, mattresses, home decor, and
to
kitchenware.
split
Online, it's a Labor Day savings
the
event. Out there,
split
it's a whole
this.
new way to enjoy your
Call it
space.
2c
Whether it's
squared
finishing
plus
touches or a
1c
total transformation,
plus
find everything you
8c
need to make your home
plus
feel
4.
more like home.
Now someone's going to ask, what if I did the other way? What if I did 8c and then 1c?
$1C?
At the end, it'll come out the same anyway. It's just your 2 binomials will be swapped.
Welcome to Parent-Teacher Night. Oh, yes, Miss Garner.
If you have one of those
do both and
airline
see what
credit
happens.
cards, you're probably
In fact, I
not
want to do it
earning
both
double
ways
miles on every
because
purchase.
there's
You're
a
right. My card
there's a
only
note
gets
to
extra
be
miles
made
on
here.
some types of purchases.
With the Capital One Venture Card, you earn unlimited double miles.
The reason I do this is so I
Well,
can
where can we use
factor
them?
by
You can use
grouping.
Capital One Venture Miles on any travel purchase.
Venture gets an A+.
Capital One, what's in your wallet?
Terms apply.
There
See
isn't an
CapitalOne.com
E
for
at the end of
details.
half. We call it factor by grouping because I now have enough things to make 2 groups. Everyone in here, y'all teenagers, everyone in here has probably been the third wheel at some point. You got those 2 friends start getting a little snuggly, and then you just feel weird, right? We were the perfect trio, and now you guys are like Animal Planet in the corner, and I'm just over here, I don't know, playing Clash of Clans or something. Like, okay? I can't group things if there's only 3 of you. However, if someone brings along a friend, well, okay, you guys go, yup, and we'll sit here and talk about how lame you are, because now I got someone to hang out with. Okay? Now, in the age of smartphones and social media, it's not as big a deal, but I tell you what, about 20, 25 years ago, that was an awkward time at Burger King. I'm going to cut this in half. You know what kind of hidden spaces are behind the ball pit? So, anyway, if I'm going to factor each half of this now, hey, look, you two, you're going to go do your thing behind the ball pit. They have a C in common. We're going to sit on the outside of the kids' playroom, just feeling awkward, but we're going to talk about how awkward that is, and it's weird. So instead, we're going to throw pickles at the window and do pickle races. Okay? Don't do that. It's gross. Be nice to the workers. But if you clean it off for them, okay, that's good. You want to make sure there's still a little bit of mustard on it, because then it'll have less friction. It's kind of like lubricated, so... Y'all, I grew up in Northeast North Dakota. There was nothing to do. We were bored. We were really bored. Now that I do this is just an uglier version of CX plus 4X. What do those two have in common? I can take an X out. Here, I can take an entire 2C plus 1, leaving that C plus 4. And that is round 5 to factor out the common binomial. Now I do say common binomial. This also works when you get to higher order polynomials. You could be able to factor an entire trinomial formula. Okay? And then you set them both equal to 0 because technically there was a equal 0 at the end of each of these. And this one equals 0, -4. Do I got to do the full thing setting equal to 0, or were we pretty good about just change the sign over this kind of business? C is at -1/2. Okay. Now I'm back up here. What if I came all the way back here and said it was plus 8C plus C? I want to be really careful about this. Right? We need that one as a placeholder. There's a lot of times I'll see, this is like the old freshman math mistake, where a kid will just say plus C plus 4, then they'll take a C plus 4 out and just leave a 2C. You see how it just kind of ends up looking goofy? Plus, if I distribute that, I don't get back to the original. I need a 1 as a placeholder. So I remember to say plus 1. Okay. So I ended up with the same binomials. But please remember that. I see that error year after year after year, especially when we start reviewing how to factor something like a quintic in PreCalc. So, all that said, that's a bunch of factoring stuff. I would like you to do the other 3 there, 7, 8, and 10. 2 got the little easy flavor to it, 10's got a little mustard. By the way, mustard isn't good. If you put mustard on food, we got problems. That's disgusting. My mom refused to do the whole soap in the mouth thing, wash your mouth out for swearing. Grandma had the bright idea of, well, just find something that he really doesn't like and make him have that. Spoonfuls, like heaping spoonful of mustard at once. Swore, completely told off the principal. Like, what, any of those, right? Ooh. Yeah. No. I never swore. Aren't you a good kid? No. I got a pinto bean stuck in my ear 2nd grade. We were pretending they were hearing aids. Got stuck, had to go to the doctor, dig it out with tools. My mom discovered just how broad my vocabulary is. Yes, sir. Remember, talk it over with your neighbors. Daily quizzes, I want you doing your thing. Everything else in class, I want you talking to your neighbors. I want you arguing it out. Make sure you got it right. How do you check these? Oh, creating. I thought it said cheating. That is not right. Nope, it's a minus. No, that's right, that's right. I got my signs right. I'm guessing the first two are pretty straightforward. Maybe we're remembering how to do things on the third one. I went straight for the throat on number 10 because what's going to make it easier on number 10 to just do it without the full process? What about number 10 makes it easier? Prime numbers. The only way that I make a prime number is with 1 in the cell. So I got the 1 and the 3 already locked in. I just got to worry about signs and then factors later. I just started randomly placing factors of 8 in those places and seeing what happened. Try it, try it, try it, no. Try it, try it, try it, no. Try it, try it. Oh, hey, that one! If you can do it, cool. If you can't, let's go through that full AC method again. Step 1, GCF if you got it. Step 2, you take A times C. What factors of negative 24 add up to negative 2? Okay? So I will split B and call this 8k squared minus 6k plus 4k. Then I cut it in half and say, what do you two got in common? We have a 2 and a k, leaving a 4k minus 3. What do you two got in common? Absolutely nothing, but we both hate those two behind the ball pit. So, 1. I shouldn't say that. Hate's a strong word. Gotta be worth the hate. Loathe? That's possible. Take that 4k minus 3 out. There you go. And then set them each equal to 0 again.
Hey, Welcome to Everything Outdoors. Can I help you find anything?
Write them as
Can you
fractions.
point us to the camping gear?
Sure,
Like-
I do.
Snowboarding? Just bought a new Nissan Pathfinder.
Both these are
It's got a
terminating
tilt-in
decimals,
4x4,
right?
And we want to hit the back
3/4,
Aisle 18.
0.75.
And the boats?
Are you sure you can do all this?
Negative
Up to
1/2.
6,000 pounds
Negative
towing, we're good to go.
0.5.
Oh, where's the
Those are
scuba gear?
both
Return to
terminating decimals, so if you wrote them as decimals, technically you're correct.
Available intelligent 4x4 cannot prevent collisions
I'm
or
gonna say,
traction in all
if,
conditions. Always monitor
if you're
traffic and weather
afraid of
conditions. Warranty
fractions, you're
capability
in
varies
the
by
wrong
configuration. See
room.
Nissan Owner's Manual for proper use.
If you're afraid of fractions, how'd you get this far?
Spicy chicken
Okay,
nugs.
because you should have worked with them non-stop throughout geometry
with a
and
unique blend
algebra
of
2.
spices, these are the spicy nugs that other spicy nugs
Okay.
wish they were. And with Wendy's new Ghost
After
Pepper
the
ranch sauce,
factoring
you'll reach new levels
is
of
the one that I have
spice.
to
So you're
teach
probably
3 years
thinking,
running,
where's the closest
because we
Wendy's?
show you in Algebra
Get the
1,
only
then we show you
6-piece
quadratic
spicy nuggets
formula, and you
worthy of
forget
their
it.
name for free with purchasing the Wendy's app.
You get to geometry,
Wendy's offer must be redeemed via the Wendy's app. Download and account registration required.
and you're told you can just do whatever way you want. I just want you to solve it, so everyone goes quadratic formula. You get in Algebra 2, we teach you it again, and then you do quadratic formula for the rest of the year. And you wonder, why do I even need to use this? Okay. Y'all know Finn? Hamilton? Yeah? Right? Okay. I got him a video from day 3 of class. Why do we even need to know how to complete the square? This is stupid. When will we ever use this? And then when we got into conic sections and we were doing it 2 or 3 times per problem, I played it back for him over and over and over and over, and I sent it to the whole class, and it means it was great. You gotta know how to do it. We're not just saying this for grins, okay? It does get used. In fact, the more comfortable you get with it, personally, I can solve quadratics by completing the square mentally that I would never be able to do with quadratic formula. Because to me, it's faster. It's broken up into just 2 solid steps if you're not afraid of fractions. So, go back to holy sheet. Man, if only all the steps were already there for me, so I never needed to worry about where am I going to find them. Okay. All the steps for complete the square right there. Stage 1. Okay, stage 1 and 2 are kind of interchangeable. In fact, as we go further on, I'll do them at the same time. They are all of your variables on the left, all of your constants on the right. Okay, treat it like a middle school dance. Boys over here, girls over there. All the awkward. Who remembers watching those 2 kids out in the middle of the floor that are the full arm length apart like this? Look like a weeble. Okay. Stage 2 is to eliminate the Canadians. Divide by A. You get rid of A. A? No? Alright. Suppose I shouldn't say that. They kind of got stuff figured out way more than us right now. Right now, what is the A term? Okay, I don't have to worry about it because A is 1. If it wasn't, you need to divide every single term by whatever that A value is to ensure that your new A value is 1. Because otherwise, it's going to mess with this completing the square process. So here's what we mean by complete the square, just kind of off to the side here. If I had a rectangle and I wanted to turn it into a square, you would kind of chop this part off and bring it up here, right? So the idea is that I would take part of that rectangle and move it up here. so that these two little rectangles are the same, this little big rectangle is all the same, if I was geometrically trying to create a square, I would always be missing this little spot right here. This is your x squared term. It's the big honk. You ever done, any of you ever worked with algebra tiles? Some kids do, some kids don't. I know our district isn't fond of them. Okay. Here would be your x terms. b over 2x, b over 2x. Here's your constant. There's the c. You're trying to find what is the magical number that goes right here that's going to complete a perfect square trinomial. Yes. After this, I add, it is always b over 2 squared to both sides. Right now, b is -4, half of that's -2, -2 squared is 4. So I'll add 4 here and here. Four comes after 3. What this allows me to do is factor the quadratic that's on the left side as a perfect squared quadratic. Look at A and C. Aren't they both perfect squares? 1 and 4. If I now have x squared minus 4x plus 4 equals 3, I can turn this into x plus 2 times, or x minus 2 times x minus 2. I can turn this into x minus 2, the quantity squared. I write it as a binomial squared, which will always be x plus b over 2, the quantity squared. Every time. We call it a perfect square trinomial for the reason that this 2 is the square root of c and half of b. It's perfect. That's what makes it perfect. I completed a perfect square trinomial. If I've completed the perfect square trinomial, I can solve using square roots. Is the last step. Square root, right? Because anything squared, if I square root, they're inverse operations. I get x minus 2 is plus or minus 3. And that's something that if you didn't have it pounded into your head back in Algebra 2, you might want to write a note off to the side right now. If there's already a radical in the problem, it's considered the principal root. You work with it as is. But if we introduce a radical as part of our process, you need to put plus and minus. If we put the radical there, you need plus or minus. Okay? And then finally, I'll move the 2 over, and it just stays a compound number. 2 plus or minus root of 3. We call it a compound number because it has a rational part and an irrational part. Just like my complex numbers had a real part and an imaginary part. Compound will have rational and irrational. And you leave it that way because that is the most accurate answer. Now, could I, next to this, also then say approximately 1.729, I think, 3.729, and 0.271. Okay. If you wanted to do that, go ahead. The white part, that's what I'm looking for. That's the correct answer. Now, again, if I go in to Next after school for a project and I tell them that I'm going to need at least 5 2x8s that are all 2 plus square root of 3 feet, I might be correct. They're going to grunt at me. And they're going to kind of get this look on the face. Okay, but if I tell them, give me about 3'8", you know what, just give me a bunch of 4 feet, then it'll be cool. Okay? This is the real world context. This is the correct answer. I always want the correct answer. Oh, no. Leave those there. Leave those there. 4, 5, green. That's why. Because you were already missing. One was variables left, constant right. Now where this gets a little dicey is like number 15. You start getting different stuff. You start getting fractions. Okay? Stage 1. Variables left, constant right. 3v squared. 9v is -5. Divide everything by a. V squared plus 3v is -5/3. Add b over 2 squared to both sides. What is b? So if I've got a 3 and I want to do b over 2, that's 3/2. Don't you dare say 1.5. Because when I square that, that's 2.25. Now you got funky decimals floating all over the place. How about instead, half of 3 is 3/2. 3/2 squared is 9/4. Now I can take my perfect square trinomial and write it as, it's always half of b oh no, fractions! Common denominators. Grab a calculator. Okay. I just care that you do the thing. By 4 is -20, by 3 is 27, and 7/12. Okay. Solve by square roots. Get b plus 3/2 is plus or minus. Ruh-roh, Raggy. Don't leave it as square root of a fraction. Remember, the square root of a fraction is a fraction of square roots. Square root of a fraction is a fraction of square roots. Because they both effectively have an exponent of 1/2. And exponents apply to the entire rational expression. So I could bring that 3/2 over. Say -3/2 plus or minus square root of 7 over square root of 12. And end up with a 4 out of 5 on 200 squares. Yeah, you better rationalize it. Okay, no radicals downstairs. You're up the road getting bad ideas. That's how you end up with someone behind the ball pit at Burger King. It was so awkward. I'm already awkward. Don't make it worse. Y'all remember to turn this into 2 root of 3?
Countdown to fall has started. This Labor Day, get ready for the season
Again,
now, in
if you
store
can't
and
fraction,
online
how'd you
at
get here?
Lowe's.
If
With
you
our new
can't
lower
simplify
prices on
radicals,
select
how'd you
bag
get here?
mulch starting at $2.88
Okay.
per bag. And select 3-quart mums at 2
Because
for $10.
12 is 4
Let's all
by
fall
3,
together
square
at
root of 4
Lowe's.
is 2.
Home to any budget, home to any
Right?
possibility. Mulch selection and
So I'll
price
multiply
varies
by square root of 3
location.
and
Mums
square root of
offer in store only.
3.
Actual plant size and selection
We'll call
varies
this
by location.
now.
Valid 826 through 9/8 while supplies last. Excludes
V
Alaska
is
and Hawaii.
negative 3 halves plus or minus. Square root of 7 by square root of 3 is square root of 21. 2 times square root of 3 times square root of 3 is 2 by 3 is 6. You have to rationalize that.
There's one for me. And one for you.
Radio ads. They say word at first too. Electric cars.
Rationalizing is specifically taking denominators and removing them. Simplifying. Simplifying radicals or rationalizing denominators. Just simplify the radical. Okay. All right. Apparently we need to go back to... Hold on. And you should have been having all of your answers in simplified radicals from chapter 4 onward last year. Oh my god. Okay, well, we're in for a rude awakening. First, I'm going to turn this square root of 12, I'm going to call it square root of 4 by 3. Specifically because 4 is a perfect square. Square root of 4 itself is 2. So this is now the square root of 7 over 2 root of 3. No radicals downstairs. He's got to get out there. He's okay, I know his dad. No radicals downstairs. Kid who's going to introduce bad ideas into the gathering. He's okay. This is the kid who claims he never swore at all when he was little. The fact that you remember that, I was in principal's office before lunch the first day of kindergarten. Jen tripped me, so I threw her into that coat rack that's bolted onto the wall. We had different childhoods. Oh boy. Square root of 3 and square root of 3 is just 3. 3 by 2 is 6. I was not. I really was not. Y'all got to be able to, like, this is should be the 4th year you've done this. Okay. Uh-huh. Eliza? Sister? Yeah. I would like you to do those too. 2. I'm going to replace 15 with something butt ugly. Or 15, whatever the top left is. There you go, 5. Yeah. Uh-huh. Never need to ask. Let's go. Y'all are big kids, you potty trained, you don't need to ask me, go. Expecting a call from someone, maybe you applied a couple of places, you're waiting on a call back on an interview. You check your phone, it says something Culver's. Okay, hey, I gotta go out in the hallway. Go. Okay. Or if I knew you from before, right now.
plus fractions, you want it to like do the whole thing where m equals this, or just leave it like that?
Oh yeah, if your result has rational number plus or minus other rational number, just find the two answers. We only leave it as rational plus irrational if it can't be simplified, right? Like if I ended up with an answer that was 5 plus or minus 2, I would just write 3 and 7.
That's correct.
-3, actually. Yeah.
Okay, these actually shouldn't have been so bad because you ended up with a bunch of whole numbers that are integers. Stage 1, variables left, constants right. Already done. Eliminate A. Already done. So, add B over 2 squared to both sides. Write it as a perfect square, always plus b over 2, so n plus 3, the quantity squared, is 16. When I square root this thing, I end up with plus or minus just 4. It's already a perfect square. Nice and easy. So, move that over. What I'm talking about is I don't want you to leave it like this, because those are both rational numbers. Since they're both rational numbers, you can simplify it further. When you have a compound number with rational and irrational parts, you can't simplify it. So you leave it like that. This, I can keep going. I write that as 1 and -7. Okay? Next up, variables left, constants right, already done. Eliminate the Canadians, divide by 4. C squared minus 2c is 1/4. Yeah. And welcome back. Add b over 2 squared to both sides, which in this case is a handy dandy 1. So when I write this as a binomial squared, I now have c minus 1 the quantity squared. 5/4 with common denominators. Another reason that I like just staying in fraction land with these, usually, the denominator of this constant over here is going to end up being a perfect square. So when I square root, I just get an integer down there anyway. Okay, it keeps your answer fairly clean. That last one where we had to have a square root of 12 on denominator, that doesn't happen as often. Square root both sides. C minus 1 is plus or minus square root of 5 over regular 2. Again, don't leave it as square root of a fraction. Make it a fraction of square roots and then simplify them each. And bring that minus 1 over. C is 1 plus or minus square root of 5 over 2. You notice I keep separating. Separate your rational friends from your irrational friends. Separate your real friends from your imaginary friends. Okay? Technically, get common denominators. Could I also have 2 plus or minus root of 5 over 2? It's still the same value, right? The difference times 2 times 2. Now they're both over 2. With like denominators. Who was it? You said you did college algebra, just to keep sharp on stuff. Did they ever let you input your answer like that? Honestly, I tried to flame last year out of my memory too. Because it's not proper. This is, I know this is the correct value. You're good, you're doing everything you're supposed to, don't worry about it. This is, you can't wear jeans every day because that's unprofessional. This is proper, okay? 1 plus or minus square root of 5 over 2. Yep. Now, I said I'm gonna make one ugly. What happens when we start introducing imaginary numbers? What happens when we start having ugly fractions? Yo, if I have a square root of a thing that's negative, square root of -1. So do exactly what we were doing before, just throw an I next to it, right? You just can't be afraid of fractions. So I am completely making something up here. I have no idea what this is going to be. Nope, you're going to do this one instead. You know what, let's go all primes. Have fun. Uh-huh. So what have I got? 10ths squared 121 hundredths. Negative 121 hundredths, negative 19 fifths. 2020. 95 hundredths, 121, 5, 6, 26, tenths.
Heard you're buying a car. I brought my calculator.
Dad, I already used Capital One Auto Navigator. I found my car online and got pre-qualified instantly. Instead of all that.
You know those things impact your credit score.
Didn't impact my credit score, Dad. Now I'm going to the dealership for a test drive and to make the purchase.
Sounds too easy.
No, it's just easy. Capital One, what's in your wallet?
Terms and conditions apply. Find out more at CapitalOne.com/AutoNavigator.
What makes the perfect workout? Being able to ride, lift, and stretch in one place with motivating instructors.
Yo.
Classes that always work around your busy summer schedule.
Not radicals. They'll simplify fractions, they won't simplify radicals.
Now what if you had it all? Right at home. The Peloton bike. Nothing like working out.
Automatically down to the,
Visit onepeloton.com to learn more.
Alpha Y equals inputting or turning into. Okay. Again, not everyone has used the TI-84 as much. If you're trying to input a fraction, second brings up all this stuff on top that's already listed. Alpha, this top row, brings up all the shortcuts that are most commonly used in the class. Alpha Y equals brings up your input menu for fractions. So that's how you get a fraction in there. If I go alpha window, these are the most common functions that we're going to use throughout the class. Alpha trace brings up all of your Y menus. Those will be handy for our regression models. I suppose I should put the problem back up there, right? Yay or nay? Oh. No? Alright, we'll just toss it down here. Okay. Yep. Well, let's find out. Stage 1. Variables left, constants right. Stage 2, divide everything by 5. Stage 3, add b over 2 squared to both sides. Right now, b is 11/5. So if I take a negative 11, if I take that over 2, y'all remember compound fractions? Dividing by fractions is easy as pie. Flip the second and multiply. Okay. What's up? The fraction 11/5 divided by the fraction 2 over 1. But then I must square it. So I add 1/21 to both sides. And if I multiply by 20 over 20, oh, I just multiplied that by 5 for some reason. That's why mine's wrong. I multiplied this by 5 instead of by 20. What I was, yeah, oops. Okay, so I had 95 plus 1. So Multiply by 20 and 20. Okay, that's a lot different. That is negative 380 over 100. Okay. Yep, there was the goof. I guess we'll just go back to it. So I got x minus 11 tenths. It's always half of b. Squared is, what's that? 100, 260, 259. 259. 573, not by 3, so 13s. I don't think it is. I don't think that has a perfect square in it. Oh, is there anyone here who has the 36X Pro? I'm in love with that calculator. This one? Black, silver buttons over here. These things are really nice because you can just type in 259 math 4. It does prime factorization of it. So it just tells you what the prime factorization of 259 is. It'll also just simplify the whole thing through an algorithm. Anyway. Add b over 2 squared to both sides. Need common denominators in order to add these. Once you have common denominators, negative 380 plus 121 is negative 259. b over 2 squared. Half of 11 fifths is 11 tenths. Squared is 121 hundredths. You need common denominators. Are we forgetting the squared, or are you just putting 11 tenths over there? Okay. And then finally, when I square root, I get plus or minus the square root of 259, not reducible, over 10i. Bring it all over to one side, x is 11 tenths. Hold on. This is considered the most proper way to write it because it's in the form x is a plus bi. Real part, imaginary, coefficient, imaginary number. That's considered the most proper way to write it. Could I have that as 11 plus or minus square root of 259i all over 10? Could I have put the I in front? Yeah, I could do all of that. But I'm just telling you, you're going to run across some crotchety math professor who wants you to do this. So let's just get that out of the way. Okay, if you need practice with complete the square, I'm going to be doing it nonstop all semester long. Even if you could do it by quadratic formula, I'm probably doing it by complete the square. Which brings us to the last one. I'm pretty sure this is the one that's kind of seared into your memory. Okay, it is also top row, fourth in from the left, quadratic formula. Okay. Do you know the quadratic formula comes from, you should have done this in Algebra 1 and 2. The quadratic formula comes from completing the square on the general form of the quadratic. It's not just someone said, "Oh, hey, look, this works." Okay? They didn't just make it up. C goes to the other side, divide everything by A. Half of B over A is B over 2A. Squared is b squared over 4a squared. Add it to both sides. Combine like terms. Square root both sides. Simplify. Bring that b over 2a back to the other side. You just complete the square on the general form. That's where the formula comes from. But once you have the formula, I think we're all pretty good with it. Better be. If x is negative b plus or minus square root of b squared minus 4ac all over 2a, the way that I always do them, and I recommend the same thing so we don't screw up negatives and exponents, I say x is negative parenthesis plus minus parenthesis squared minus 4 parenthesis parenthesis, those butt cheeks everywhere, and put numbers into them instead. What's b? What's a? C. Simplify in parts. The parts that can be simplified simultaneously are outside, radicand, 16 minus 60, and denominator. Well, perfect square goes into 44.
Inside the Home Depot.
Since I can write the square root of negative 44 as negative 1 by 4 by 11, square root of 4 is 2, square root of negative 1 is I. I'm going to rewrite this as 4 plus or minus 2i root of 11 all over 2.
So, get back out there with store-wide savings for house-wide doing.
That is the correct answer, but it's not simplified yet. Do not, this is freshman math. You kill a puppy if you do this.
Taco Bell
Don't do that.
presents a get-out-of-bedtime story.
Why not?
It's time to wake up from this amazing dream, even though you're jet skiing on lemonade. How exciting!
This is also over
look
2.
at that.
4 is
You
also
just won
over
the
2.
lottery. Is that a castle?
Math is communist. What you do for one, you do for all.
What's better than swimming in space?
Okay.
Just wait for
You
the
take a
big
2 out of
reveal.
all of
It's
them
Taco
and call
Bell
that
breakfast,
2
and it's actually
plus or
real.
minus
So it's time
I
to wake
root of
up
11,
and bid your dreams
or
farewell.
if you want to be
Because
prim and
toasted
proper,
breakfast burritos are waiting
square root of
for you
11
only
I.
at Taco Bell. Participating Taco
I don't
Bell
worry about the bottom
restaurants.
unless you need more practice with quadratic formula. Okay? Your homework is just solving quadratics like you're back in Algebra 1. Okay?